Hey math enthusiast, I'm here to continue the notes on section 1.5, which deals with angle-pair relationships. So for number 7, they want me to solve for the variable in this figure. First thing I notice is that this angle on the right is 90 degrees. Now in this case, I'm going to use the angle addition postulate and figure out that that large angle, angle ABE, is equal to the sum of the measure of angle ABD plus the measure of angle DBE. From there, I'm going to fill in what I do know. Well, I just wrote down that DBE is 90 degrees. Now, as far as ABE goes, it appears to be a straight angle, which tells me that it equals 180 degrees. So now I can use that information to solve for ABD. So if I subtract 90, it looks like I'm left with 90 equals the measure of angle ABD. So let's mark that in our picture. I know this angle on the left is a right angle. Now I'm going to use the angle addition postulate again, and I'm going to focus on the measure of angle ABD. So I'm just going to focus on the left side of my picture over here. And I know that the measure of angle ABD is equal to the measure of angle ABC plus the measure of angle CBD. Next, I'm going to fill in the information that I do have. I already determined that ABD is 90 degrees. They gave me a measurement for ABC. They said it was 11x minus 2. And for CBD, I'm told that it's 5x minus 4. Take a minute, work through this equation on your own. I'll reveal the answer in a couple seconds. Looks like x equals 6, which means that angle ABC would be 64 degrees and angle CBD would be 26 degrees. Now for the next example, there's two different variables we have to focus on. We have x in these two expressions and then y down below. Let's just focus on these two angles up top. It looks like these two together form a linear pair. So in that case, I know that the angle on the left, 16x minus 18, plus the angle on the right, 10x plus 3, together they have to equal 180, since they form a linear pair. Once we have our equation set up, take a minute, go through, try to solve it on your own. I'll reveal the answer in a couple seconds. Looks like x is going to equal 7.5. So now I could take this value and plug it back in to solve for these angle measures. When I plug it in, this angle on the left, I end up with 102 degrees. And when I plug it in this angle on the right, I end up with 78 degrees. Now, I still have to solve for y. Well, if you remember what we discovered earlier, these vertical angles on the left and the right are going to have the same measurement. So I know that this angle on the right must equal 102 degrees. Now you can set up an equation to solve for y. You know 12y equals 102. Therefore, y equals 8.5. Now, for question number 9, once again, I'm trying to solve for two different variables. So we have x and x across from one another, and then the y's and the y's across from one another. Once again, I can use that principle about my vertical angles. I know that these angles across from one another have to be congruent. So their measurements are going to be equal. So I can take that expression 9x minus 2 and set it equal to the 5x plus 14. And for the other angles, I can do the same thing. I know these vertical angles on the top and the bottom, 9y minus 7, is going to be equal to 6y plus 44. Now that we've set up our equations, take a second, go through, and solve for x and y. I'll reveal the answer in a couple seconds. So it looks like for x we end up with 4 and y we end up with 17. Now if I take that x value and plug it back in up here, I'm going to end up with 34 on the left and 34 on the right. So it looks like that one works out. And if I plug in 17, I'm going to end up with 146 up top and 146 down below. So it looks like y equals 17 checks out as well. Now, for this last problem, I'm once again trying to solve for multiple variables. So let's come up with a couple different equations. I can see that right here I have a straight angle, so that means these two angles are going to form a linear pair. So now I know 3y minus 2x plus 15y minus 7x equals 180. Next thing I'm going to do is just clean up that equation. Looks like I have 18y minus 9x equals 180. Let's take a look at another pair. These two on the right-hand side also form a linear pair. So now I also know that 15y minus 7x plus x plus 9y equals 180. I'm going to clean this equation up as well. Looks like I'm going to end up with 24y minus 6x equals 180. And I can come up with one more equation because I do have some vertical angles here since I have two lines that intersect. These two angles, the bottom right, that x plus 9y, is going to be equal to the top left, that 3y minus 2x. In this case, we can clean this equation up, get all our y's on one side and all our x's on the other side. Now let's clean this up a little bit. So what I'm dealing with is a system of equations. I have two variables and, well, in this case, three equations, but I really only need two of these equations. Now, if you remember, to solve a system, you have three options. You can graph them, which we'll try to avoid. You can use elimination, or you can use substitution. In this case, elimination or substitution will be easier. And I think I'm going to stick with substitution, and you'll see why in a second. Let's focus on this last equation here. So 6y equals negative 3x. What I'm going to do is I'm going to divide both sides by negative 3. What that's going to leave me with is negative 2y equals x. So I know that in any of these equations, I can replace x with negative 2y. So let's take this top equation, and I'm going to start off with 18y minus 9, and instead of writing x here, I'm going to fill in negative 2y equals 180. Now the purpose of this is to get rid of my x's. Now I have one equation with just y's, which is going to leave me with 18y plus 18y equals 180. So I end up with 36y equals 180. In this case, it looks like y equals 5. Now I can use this equation replace my y, so negative 2 times 5 is going to equal x, which shows me that x equals negative 10. There are my two solutions. Now, we do have a negative here, but it's still going to give me positive angle measures after I plug it into my values up above. I want to take a second to show you guys a different method I can use to solve this. So let's focus on our top two equations. 18y minus 9x equals 180, and 24y minus 6x equals 180. Now, in this case, I want to try to use elimination. So therefore, I want to try to eliminate either my x or y variable. Let's try to focus on eliminating one of the x's. In this case, I'm going to have to change my equation. I want to make both of them so that they read negative 18x and positive 18x. So in order to do that to the top equation, I'm going to have to multiply it by 2. What that's going to leave me with is 36y minus 18x equals 360. And for the bottom equation, I'm going to have to multiply by negative 3. That's going to leave me with negative 72y plus 18x equals negative 540. The purpose of this, obviously, is to eliminate something. When I combine these two equations, when I add them up, what's going to happen is my x's cancel out. I'm going to end up with negative 36y equals negative 180. Similar to what we had before, but now both sides are negative. Well, when I divide by negative 36, I just end up with y equals 5. Now, if you want to solve for x, all you have to do is take this value and plug it back in to either of these equations to try to get x by itself.